Hello friend, in this video lecture we are going to learn the boundary value problem and method second cubic spline method. The boundary value problem is of the form y double dash plus f y dash plus g of y is equal to r, that is 1, and set here x is equal to xi, y is equal to yi. Then equation 1 implies yi double dash plus f of I yi dash plus g of I yi is equal to ri, and set here yi of double dash is equal to mi. Use the expression 2 and 3 below, then we get mi plus f of I into bracket h by 6 into bracket 2mi plus m of I minus 1 bracket complete plus 1 by h yi minus yi minus 1 bracket complete plus giyi is equal to ri. That is equation number 2. Then second, mi plus fi into bracket minus h by 6 into 2mi plus m of I minus 1 plus 1 by h into bracket y of I plus 1 minus yi bracket complete plus g of I y of y is equal to ri. That is equation number 3. Then write the problem. First problem, example 1. Very important problem of this method. Given the boundary value problem, x square y double dash plus xy dash minus y is equal to 0, and y of 1 is equal to 1, and y of 2 is equal to 0.5. Apply cubic spline method to determine the value of y of 1.5. Solution. Given differential equation is x square y double dash plus xy dash minus y is equal to 0, then y of 1 is equal to 1, and y of 2 is equal to 0.5. Then y double dash plus y dash upon x minus y upon x square is equal to 0. Divide by x square on both sides. Then we get y double dash is equal to minus 1 by x y dash plus 1 upon x square y, and set here x is equal to xi and y double dash of xi is equal to mi. Then we get mi is equal to minus 1 upon xi yi of dash plus 1 by xi square yi. That is equation number 1. Then comparing this equation with mi is equal to minus fi yi dash minus gi yi plus ri, we get fi is equal to 1 upon xi and gi is equal to minus 1 upon xi square and ri is equal to 0. Then write the formula mi is equal to minus fi into bracket minus h by 6 into 2mi plus m of I plus 1 plus 1 by h means third equation of given formula, y of I plus 1 minus yi minus gi yi, and here I is equal to 0, 1, 2 up to the term n minus 1. Then mi is equal to, then second formula is from equation second minus fi into bracket here h by 6, here negative here positive, 2mi plus here mi plus 1 and here mi minus 1 plus 1 by 6 1 by h into bracket yi minus yi of I minus 1 plus gi yi, and here I is equal to 1 to n. This implies mi is equal to, here fi is equal to 1 by xi, then here minus 1 upon xi into bracket minus h by 3 mi means multiplying the h by 6 to this bracket, and then we get minus h by 3 mi minus h by 6 mi plus 1 plus y of I plus 1 minus y upon h plus gi is equal to 1 upon xi square yi. That is equation number 2. And then in second equation mi is equal to minus 1 upon xi into bracket, here h by 6 is positive, then we get h by 3 mi plus h by 6 mi minus 1 plus yi minus 1 upon h plus 1 upon xi square yi. That is equation number 3. From equation 2 and 3, we calculate the value of m0 and then solve. Here given that y of 1 is equal to y of 0 is equal to 1 and x0 is equal to 1, x1 is equal to 1.5 and x2 is equal to 2, and we know y of 2 is equal to y2 is equal to 0.5 means 1 by 2. Now we determine y of 1.5, that is equal to y1, and for I is equal to 0 in equation 2, in this equation 2 put y is equal to 0, then we get m0 is equal to minus 1 upon x0 into bracket, here h is equal to 1 by 2 minus 1 by 2 upon 3 m0 plus 1 by 2 upon 6 I is equal to 0. This value is m1 and plus y1 minus y0 upon 1 by 2 plus 1 upon x0 square y0. Then put the value, if here x0 is equal to 1 means minus 1 into bracket minus 1 by 6 m0 plus 1 upon 12 m1 plus 2 y1 minus y0, and y0 is 1, put the value of 1 plus x0 is equal to 1, therefore 1, and y0 is equal to 1, therefore this is equal to 1, is equal to 1 by 6, multiplying the minus sign by for this bracket, 1 by 6 m0 plus 1 by 12 this value, this sign is minus, this is minus, then we get 1 by 12 m1 minus 2y1 plus 2 plus 1, that is equal to m0 is equal to 1 by 6 m0 plus 1 upon 12 m1 minus 2y1 plus 3, here 1 and this is equal to 3. Multiplying this equation by 12, then 12 m0 plus m0 2m0 plus m1 minus 24 y1 plus 36, and we know this in first we given that 10m0 is equal to minus m1 plus 24y1 means these are 2m0 on right side. Then we get the equation 10m0 minus m1 plus 24y1 is equal to 36. That is equation first. For I is equal to 1, in equation 2, from above procedure is used and solve, we get 16m1 minus m2 minus 32y1 is equal to minus 12. That is equation 2. Same procedure of above is used. And for I is equal to 2 or 1 in equation 3 implies that we get the equation m0 plus 20m1 plus 16y1 is equal to 24. That is equation third. Means same procedure for first is used, that method is used in third, then we get equation third. And for I is equal to 2 in equation 3, we imply that m1 plus 26 m2 minus 24 y1 is equal to minus 9. That is equation number 4. Then eliminating m0, m1 and m2 from this equation, from this system of equation, we obtain y1 is equal to 0.65599, since the exact value of y1 is equal to y of 1.55, that is equal to 2/3. The error in the computed value of y1 is 0.01, and which is about 15% smaller. By eliminating m1, m0, m1, m2, then we use the procedure equation first multiply by minus 10, equation first minus 10 multiply by equation 3. Then we delete m0 is eliminate, and we get the equation m1 and y1 are remain. That is equation number 5. This procedure is used for eliminating the m0, m1, m2, and 26 multiply by equation second and minus equation 4. m2 is eliminate, is delete, this m2 is delete, and m1 and y1 are remain. This is equation number 6. and then solve equation 5 and 6 simultaneously, and we get y means value of y1 is given, and this is your problem. Is this procedure is used after finding these four equation, first, second, third and fourth, then elimination of m0, m1, m2, we use this procedure. Equation 1 minus 10, equation 1 minus 10 multiplied by equation second, we eliminate the m0, means m0 is deleted, then m1 and y1 is remain. That equation is taken as 5, and equation 2 multiplied by 26 minus equation 4, m2 is delete, and then m1 and y1 remain. And that equation is taken as 6, and then by solving this 5 and 6 we get the y1, and that y1 is this value 0.65599, and this is the exact value of y1 is 2/3, and then difference of this is equal to 0.01, and which is about 15% smaller. सिलेबस पूर्ण संपलेला आहे. 5 युनिट आपले झालेले आहे. थँक्यू.